Hi, today we're going to talk about how to find the p-value when the t-test statistics is negative. So before we get started, let's refresh a few things. First, the p-value is not the probability that HO is true. There's a lot of confusion about that. You cannot make that statement. It is incorrect. Second, follow this rule. If the p-value is more than alpha, reject HO. Okay? Keith Bauer said once, if the p-value is low, HO must go, and that is meant to help you remember when to reject HO. Also, the p-value is the quantity of evidence against HO, but there is a catch. A small p-value has large evidence against HO. So if the p-value is small, there's a lot of evidence against HO. Otherwise, there isn't. The p-value is a probability and it cannot be more than 1. Okay? So now let's see how we're going to approach this. Let's say we did a test statistics, T. Here's our HA. It's very critical that you know what HA is because you need to know the sign, the HA sign. So the sign of HA tells us the direction to go once we know the test statistics. Okay, here's the test statistics, and here is the degrees of freedom, which means this is the row we follow on the table. Now let's draw a T distribution. Here's the shape of the distribution, center 0, test statistics minus 3.4, and now we look at HO. HO says go to the left, so this area I am shading right now is where the p-value is. So the p-value goes from the test statistics that way to minus infinity. Now we go to the t-table. Once we get there, we look around these numbers, and what we're going to see is that they're all positive. So how can I find the negative? Well, what we actually do here, we think of this test statistics as positive. We go to the table looking for a positive. When we find it, we keep in mind that when we did this drawing and shaded, we shaded a smaller tail, not this larger area to the right, but this smaller one. So when we get to our table, we're going to be looking at a positive side somewhere here on the table. We're going to keep in mind that even though HA says go to the left, and we did go to the left, we took the smaller side. So when we're looking at our table, we are going to take the smaller side. Okay, so minus 3.4, degrees of freedom 20. We go to the t-table, look for degrees of freedom 20. Here's the 20. We look for a place where we put 3.4 between two numbers, and it's right here. So at this point, we know we have to go up all the way, look for the headings of these columns, and our p-value is located somewhere between 0.025 and 0.001. However, we remember that when we did our drawing, we follow the smaller tail. So here, the smaller tail is actually going this way. So we're going to say that the p-value starts somewhere here and goes to the right, to the smaller tail. Now, who was the last one we saw when we came from the big areas to the smaller? The last one was 0.25. We passed it. So we know we are a little less than 0.025. So the p-value is a little less than 0.025. So back here, we're going to say that this p-value is less than 0.025. Okay, now taking on another example similar to that, but note here HA says go to the left. Well, this p-value was supposed to be negative, so let's make it negative. And let's switch side here. Okay? So this is what we have now. Here's the shape, same shape. I still have my minus 3.4, but note, HA says go that way. So if we look carefully now, we are going this way. So the p-value covers this whole area. The p-value is actually the whole, almost the whole shape. So this is the whole area where the p-value is. So we need to be careful when we look at the table not to make a mistake. So let's see in the table the absolute of this, which is positive 3.4. When we get there, we're going to find a number between two columns. We are going to go towards the larger area, okay? Which means that we are going to be on the t-table at degrees of freedom 20 and positive 3.4. We're here again, and we go up to the headings of these columns. We get here. Now, we recall that our drawing shows that the p-value covers most of the distribution. So most of it is to the left of that mark. Okay? So how much is it to the left of this mark? Well, the whole area is 1. So this area to the left, which is the big piece, is 1 minus this area. So we go back here. We're going to say that this p-value is 1 minus 0.0025 at least. Okay, so the p-value is at least 0.9975. Why at least? Let's take a look. Because if we had found a test statistics right matching one of these numbers in this column, then this would be the precise p-value. But the actual p-value we found is somewhere where this line is. So 1 minus 0.025 is an understatement. We actually have a little more area here. So at least 9975, but we know there's a tiny bit more, maybe that length. So that shows why that's the p-value. So don't forget that you just take the absolute, but keep in mind the drawing, because if we cover most of the area, then this p-value has to be very large. Okay, so that's why we do the 1 minus 0.0025. So some students have the habit of saying, yeah, it's between 0.0025 and 0.001. Well, that's not correct, because look, in this case, it's not between 0.0025 and 0.001. So saying that the p-value is between two numbers is not sufficient. You have to be correct and complete, and that's the correct answer. I hope this was helpful, and I'll see you next time.